Okay, let's start off this video by looking at this problem. Solve x squared equals 9. So we're looking for a number whose square is equal to 9. And it turns out there's actually two possible answers. One is 3. 3 squared is equal to 9. So x equals 3 would be one answer. But the other answer is that negative 3, when you square it, also spits out 9. Because negative 3, the quantity squared, means you multiply negative 3 times itself 2 times, and a negative times a negative should be a positive. So negative 3 squared should also be 9. So our answers here are x is equal to either 3 or minus 3. Sometimes we'll abbreviate this by just saying x is equal to plus or minus 3. Okay, these two numbers are called roots of 3, or square roots of 3. They're the origin of the number 9 when you're talking about squaring. What's the root or origin according to squaring? So square root. So 3 and minus 3 are square roots of the original number 9. Okay. We need a symbol for this. We don't want to have to write square roots over and over again, and so our symbol is going to be the following. 9, and then kind of a division bar with a little extra line hanging off the end. Sometimes, if you see it typed, it'll be a curved line instead of a straight line. Okay, one thing we have to be a little careful about, we talked about this problem, x squared equals 9 has two answers. But this is a mathematical symbol. I want a mathematical symbol to only have one possible meaning. I want everybody to look at this and think of the same possible answer. And so that's the idea of a principal root. It's the primary or the main one. Most of the time, if we're talking about a root of 9, we're talking about counting things, or we're talking about whole numbers. And so it makes sense to say, well, the main answer would be the positive one, or the principal answer would be the positive one. So this symbol square root of 9 is going to be representing the principal or primary or positive root of 9. And it turns out it'll always be positive, or it could be 0. We'll talk about 0 later. So if I wanted to talk about the other answer to this problem, the negative 3, I would instead use a symbol. I would just put the minus out front. So a lot of times when we take a square root, we're going to use the radical symbol. This symbol is called a radical. But it's denoting a square root. And if I'm talking about the positive root versus the negative root, I will explicitly put a plus or a minus sign. If there isn't a sign, then we're implying that that's going to be the positive one, the principal one. Okay, so that's what we mean by principal roots. Let's now make life a little bit more complicated. Let's look at a cube. So solve x cubed is equal to 8. We need to find numbers that when you cube them, when you multiply them by themselves 3 times, they spit out 8. And so I want mystery number times itself 3 times to spit out 8. You probably know what that number is. Multiple choice, just try numbers one at a time. 1 doesn't work, 2 does work, it's 2. So if we multiply 2 by itself 3 times, we get 8. And so the answer here would be x equals 2. Okay, so I'm not actually doing the steps of solving this problem or the last one. I'm just showing you this is what the answer happens to be. We don't want to call this a square root of 8 because a square root is a root by squaring, or the origin of the number according to the operation of squaring. Here the operation isn't squaring, the operation is cubing. And so it doesn't make sense to call it a square root. Instead, we're going to call it a cube root, since cubing is the name of this exponent, or the name of this operation. So the symbol we're going to use is the cube root of 8 is equal to 2. Notice I only wrote down one answer this time. I didn't write down both the positive and the negative. Let's take a look at -2 and see why exactly that is. Okay, so let's see. If I multiply -2 cubed, or -2 times itself 3 times, we would have a product of 3 negative numbers. And when I multiply 2 negative numbers, they end up spitting out a positive, but then we still have one more negative number. So our answer is going to be negative. So -2 cubed would actually be -8. And so -2 is not actually an answer I could plug in for x in the original problem. Instead, it seems like -2 is the cube root, or the origin of the number according to cubing, of this number -8. So instead of saying -2 is the cube root of 8, it seems like in this case we actually have the cube root of -8 spits out a -2. So this is something that's important. Positives and negatives are going to act a little differently depending on if the root is an even number or an odd number. So let's just take that for granted for one more second, and let's look at one more example, and then we'll try and pull everything together and come up with an overall theme. The other example I want to look at is if we can take a cube root of a negative number, what happens if we take an even root, like a square root of a negative number? So let's try one of those real quick. Okay, so let's try and see if we can find a number that is the square root of -4. So if x is the square root of -4, then x squared would be equal to -4. It's the square root, or the root under squaring. So we're looking for a number that multiplied by itself spits out a -4. And so just think about some numbers that might square to be 4 or -4, and 2 and -2 are the logical numbers to try. 2 squared would be 4, which is not what we're looking for. Sad face. -2, maybe it's -2. -2 squared would be -2 multiplied by itself 2 times. But a negative times a negative spits out a positive, and so this is also a positive 4. Also, sad face. You can try as many other numbers you want. You're not going to find an answer that multiplied times itself spits out a -4. And here's kind of the reason why. If we have a positive times a positive, it's always going to be a positive. If we have a negative times a negative 2 times, that's 2 negatives, which should be a positive. And so our squares always spit out positive answers, which means we can never get a -4, and we can never take a square root of a negative number. Okay, so we have some different things happening for evens and odds and positives and negatives. Let's try and write down the rule so we can kind of figure out, okay, here's the general theme. Okay, so a square root let's think about it this way. So if we have a root of a particular number, we have some cases based on, is the number up top even or odd? Is the number inside positive or negative? And we said if we have an even number and a positive, so like square root, turns out fourth roots will be the same as square roots. Then what's going to happen is we're going to have 2 answers. On the other hand, if n is even and a is negative, then, like we just saw with the square root of -4, that's impossible. There isn't such a number. I'll write it this way. It does not exist. Okay, which is actually the answer to the previous problem. What is the square root of -4? It doesn't exist. There is no such answer. So you could write no solution, does not exist, anything like that. Anything that says is impossible. Okay, if n is odd, like the cube root examples, the root is a cube root, 3 being an odd number. If a is positive, when we took a cube root of 8, we only got one answer, and it was a positive answer. When we took an odd root, like a cube root of a negative number, we did the cube root of -8, we got one answer, and it was a negative answer. And there's one thing that I haven't put on this summary so far, which is roots of zeros. It turns out 0 is going to be easier than other numbers. What number could we stick in there so that when you multiply it times itself, it spits out a 0? Well, 0 times 0 is 0. That's the answer. So the origin of the number 0, or the root of the number 0, is going to be 0 itself. So 0 is actually going to be an easy case, and it's going to be the same thing for cube roots or fifth roots or fourth roots, anything. We're always going to end up with a 0.